Welcome to the Deep Dive, where we get into the weeds of the latest research. Today we're tackling a really interesting paper called SSRL, Self-Search Reinforcement Learning.
Yeah, this one's got some cool ideas. It's from researchers at Tsinghua University, Shanghai AI Lab, and others.
And it dives right into a big challenge with large language models, LLMs. You know how they often use external tools like search engines for tricky questions?
Right, which works, but it gets expensive and slow, especially if you're trying to train them with reinforcement learning, RL. All those external calls add up.
Exactly. This paper, though, it kind of flips that. It asks, what if the LLM already has enough world knowledge packed inside? Enough to simulate the search process internally.
That's the core concept, self-search. The LLM basically acts as its own search engine. It generates the query, finds the info, all within its own parameters, no external calls needed.
Like it's searching its own internal library. In SSRL self-search reinforcement learning, that's the mechanism they use to make this internal search even better, right? To boost that capability using RL.
Precisely, making the models more autonomous, more efficient.
Okay, so for that quick takeaway, that first-minute summary for you listening, what are the absolute key insights here? First insight. LLMs have this surprisingly vast amount of internal world knowledge, and this knowledge can be pulled out effectively for tasks that usually need search, hitting some really high-performance ceilings on benchmarks.
Second, this SSRL training method, it lets the models tap into that internal knowledge much more powerfully. So they actually perform better sometimes than models using external search. Plus, it helps ground the answers in the model's own data, which can reduce hallucination.
And third, this is really practical. Models trained this way show great sim-to-real transfer, meaning the skills they learn searching internally carry over when they do use real external search engines. This could slash training costs.
Definitely a big deal for deployment.
Okay, let's dig in deeper then. How does this self-search actually work under the hood? We're kind of used to models doing full real search, hitting Google or semi-real, using something like Wikipedia.
Right, but this paper focuses on full sim search, fully simulated. The LLM, the policy model itself, generates everything. It's like it's having a conversation with itself to find the answer.
So how does that internal conversation, how's it structured?
They use this neat structured prompting. It guides the LLM. First, it outputs some thinking, laying out its reasoning. Then, if it needs info, it generates a search query.
But internally, right.
Internally.
So.
And then, critically, it answers its own query. It auto-regressively generates the text inside these information tags.
Ah, okay. So it finds the info within itself.
Exactly. It might loop through that think, search, get information a few times. Then finally, it provides the answer. It's a whole chain of thought, but all in one go, inside the model.
Wow. And that leads to this idea of repetition, right? Inference time scaling. Tell us about pass at K.
Yeah, pass at K is a key metric here. Imagine you run the same prompt, the same question, through the LLM K times. So you get K different potential answers or reasoning paths. Pass at K measures the accuracy you get if you just consider the best result out of those K attempts. Did any of them get it right? It's trying to find the upper limit of what the model can do, what knowledge is actually in there somewhere.
So does it help? Running it multiple times?
Massively. They found a clear scaling law. As you increase K, the number of samples, the pass at K accuracy consistently goes up.
Got numbers on that.
Oh yeah. On the Bamboozle benchmark, which is pretty tough for Verge, a Lama 3.18b instruct model hit 87.2% accuracy at pass at 1,024.
124 samples.
Yep. Compared to its pass at one score, that was 150% improvement.
Whoa, that's huge. It means the knowledge is there, it just needs coaxing out sometimes.
Exactly. It knows more than it lets on initially. And even crazier on BrowseComp, which really needs good search, models like Quinn 2.514b and that Llama 8b, they actually beat external search systems like OpenAI's O1 model at high values of K.
Beat external search just by thinking harder internally?
Essentially, yes. By sampling their internal knowledge enough times, it really highlights how much information is packed into these models.
That's wild. What about comparing different models? Any surprises there?
Definitely. You might expect models strong in reasoning, like maybe Quinn based on past results in math, to ace this too. But actually, the Llama models generally showed better intrinsic self-search ability here.
Huh. So self-search skill isn't perfectly correlated with, say, math reasoning skill.
Seems not. Which is an interesting nuance, and maybe even more striking. Smaller models, like that Llama 8b, could sometimes match the accuracy of models nearly 10 times bigger, like the Llama 3.170b model on Trivia QA.
Just by using this repeated sampling Passet K.
just by using Passet K. It suggests you might not always need the biggest model, just smarter ways to access the knowledge already inside the smaller ones. It's about unlocking potential.
It's like the model saying, hang on, I know this, let me try again. Ah, there it is. But does just giving it more room to think help? Like more thinking tokens or encouraging it to do multiple rounds of self-search?
That's where it gets counterintuitive. They tested that, even giving it prompts like, wait, to force reflection.
Did more think?
Often, no. Or only marginally. Under the same total token budget, just adding more thinking steps, sometimes even hurt performance.
Really? Why would that be?
The thinking is, for these kinds of search-heavy tasks, efficiently using the knowledge you already have might be more important than long, drawn-out reasoning chains. It's about effective retrieval, not just pondering.
Quality of knowledge, access over quantity of computation, maybe.
Something like that. But okay, even if Passet K shows the answer is in there somewhere across multiple tries, how do you pick the right one if you don't know the ground truth? They looked at majority voting, right? Maj at K?
Yeah, just picking the answer that shows up most often across the K samples.
And the improvements there were pretty marginal, much less impressive than Passet K.
So the model has the knowledge, but it's hard to reliably extract the single best answer just by voting?
Exactly. It hints that the internal knowledge might be fuzzy, or maybe the model isn't confident enough to consistently surface the best answer without specific training, which leads us neatly into SSRL.
Right, self-search reinforcement learning. This is where they train the model to get better at this whole internal process.
Precisely. They frame it as an RL problem. The LLM, the policy model, learns to be both the reasoner and its own search engine, optimizing its ability to retrieve and use its internal knowledge.
So it's learning how to search itself better. What were the key training techniques they used?
Two main innovations stand out. First, information token masking. This is clever. Even though the LLM generates the information content itself,
The stuff it found internally.
right, during training, they mask that information. They hide it from the model when it's calculating its next step or loss.
Why hide information it just generated itself?
It forces the model to rely more on the understanding derived from that information, integrating it into its reasoning, rather than just superficially copying the retrieved text into the final answer. It encourages deeper processing.
Ah, I see. Promotes genuine understanding over mimicry. What was the second thing?
The composite reward function. It's not just about getting the final answer right or wrong. It has two parts. An outcome reward, simple, +1 if correct, -1 if wrong. But crucially, it also has a format reward.
Format reward. What's that?
This penalizes the model if it deviates from that structured think, search, information answer process. It acts like guardrails or scaffolding.
So it rewards the model for following the correct internal search steps.
Exactly. It ensures the model maintains that coherent, iterative self-search process, which they found is vital for this to work well.
Makes sense. And did it work? What were the results?
Yeah, pretty strong results. SSRL-trained models, like variants of Llama 3, consistently beat previous RL methods like Search R1 and Zero Search on QA benchmarks, both general and multi-hop.
So this internal-only approach really paid off in performance.
It did. And interestingly, they found instruction-tuned models were much better at internal self-search, while the base models were still better when given external information.
So different model types are optimized for different knowledge sources.
Seems that way, which has implications for how you might choose a model or fine-tune it. And practically, SSRL was way faster to train 5.5 times faster than Zero Search in their tests.
Because it's all simulated. No waiting for real API calls.
Exactly, it's all offline. Plus, the training was more stable, avoiding the collapses sometimes seen with other methods trying to learn from external tools.
They also mentioned something about on-policy being important.
Yes, critically important. The model providing the internal information needs to be the current learning policy model. Using an older, frozen version of the model as the knowledge source led to a dramatic collapse in performance.
So the model has to learn to search itself as it's learning to reason better. It's deeply integrated.
Totally integrated. And they also noted that certain RL algorithms, particularly GRPO, which tends to do more exploration or rollouts, worked better here, likely because those extra internal rollouts are basically free in this simulated setup.
Okay, this is all about training purely internally. But how does that translate to the real world, where you might want to use an external search engine sometimes? That's the sim to real part.
Exactly, sim to real generalization. And this is another really cool finding. Models trained purely with SSRL in that simulated environment
Yeah.
can actually adapt pretty seamlessly when you give them access to a real external search engine like Google. during inference time. The skills learned in simulation transfer surprisingly well.
So the internal training doesn't lock them out of using external tools later.
Not at all. In fact, their performance often improves further when they get access to real search results, especially if they can do a few rounds of real searching.
And how do they compare against older methods when using real search?
Generally, the SSRL trained models still outperform the Search R1 and Zero Search baselines, often needing fewer calls to the external search engine to get there. More efficient use of external resources.
That efficiency is key. They had a trick for that too, right?
Yeah.
Something about entropy.
Yes, entropy-guided search. A very neat optimization. Basically, the model estimates its own uncertainty about the internal search query it generated.
Like how confident it is in its internal search direction?
Kind of. If the entropy is high, meaning it's uncertain, the queries may be a bit vague, then it triggers an external search. If it's confident, low entropy, it just relies on its internal self-search.
Smart. Only search externally when you really think you need it. Did it save many searches?
Quite a few. It reduced the frequency of external searches by 20% to 42%, depending on the setup, while mostly maintaining the same level of performance. Big potential cost savings there.
Definitely practical. Though you mentioned one caveat with the Lama model.
Yeah, just an observation that the Lama 8B model, while good, sometimes didn't seem to fully leverage the external information it received as well as one might expect. Suggests maybe a small gap in integrating self-gathered versus externally provided knowledge for that specific model, something to look into.
Okay, fascinating stuff. And they pushed even further, exploring test time RL, TTRL. That sounds familiar from other domains.
It is. TTRL is an unsupervised RL technique, often used for improving things like math or code generation at test time. Adapting the model on the fly. They applied it here to self-search.
And how did that go? More surprises.
Quite a few. First off, TTRL often performed even better than the standard SSRL GRPO trained models. The Lama 3.23b model saw a huge average boost, like 59%.
Wow. So TTRL generalizes really well to this self-search task, too.
It seems so. And there was this browse comp anomaly. The smaller models trained with TTRL got really good scores on browse comp, but not necessarily by following the usual search then answer pattern.
How did they solve it then?
Often by identifying a potential entity or answer first, and then using internal search, mainly to check if it met all the requirements of the query. A different kind of strategy emerged.
That's really interesting. It suggests unlocking internal knowledge might lead to completely different ways of tackling problems.
It could, yeah. It shows the potential for novel reasoning paths when you focus on internal capabilities. However, TTRL had a bit of downside in the Sim2 real aspect.
Oh, what was the issue?
Because it optimizes so heavily for the internal knowledge during test time, it can become a bit too reliant on it. Makes it harder to adapt back to using real external search engines effectively. Sometimes the behavior became too deterministic, leading to a performance drop or collapse in the real-world setting.
Ah, so a trade-off. Super optimized internal search versus flexibility for external tools.
Exactly, a classic AI trade-off, really.
Okay, let's try and wrap this up then. We've dived deep into SSRL, the self-search reinforcement learning paper. The big takeaway seems to be LLMs aren't just users of external tools, they have potent internal knowledge.
They're internal knowledge providers, powerful simulators, and SSRL is a way to unlock and really amplify that built-in capability.
So why does this matter to you listening? Well, it points towards more autonomous LLM agents, ones that are potentially much cheaper and faster to train because they rely less on constant, costly external API calls.
It really changes the landscape for building capable agents, how we think about their training and their inherent knowledge.
And maybe a final thought to leave you with. If these models get really good at searching their own minds, becoming more self-sufficient world models, what happens next?
Yeah, what kinds of new reasoning or problem solving could emerge when an AI can deeply explore its own internal knowledge base before it even looks at the outside world?
It feels like we're just scratching the surface of what these models truly know and how they might think. Exciting times ahead.